A multimeter or a multitester, also known as a volt-ohm milliammeter, is an electronic measuring instrument that combines several measurement functions in one unit. A typical multimeter can measure voltage, current, and resistance. Analog multimeters use a microammeter with a moving pointer to display readings. Digital multimeters (DMM) have a numeric display, and may also show a graphical bar representing the measured value. Digital multimeters are now far more common due to their cost and precision, but analog multimeters are still preferable in some cases, for example, when monitoring a rapidly varying value. A multimeter can be a handheld device useful for basic fault finding and field service work, or a bench instrument which can measure to a very high degree of accuracy. They can be used to troubleshoot electrical problems in a wide array of industrial and household devices such as electronic equipment, motor controls, domestic appliances, power supplies, and wiring systems. Multimeters are available in a wide range of features and prices. Cheap multimeters can cost less than $10, while laboratory-grade models with certified calibration can cost more than $5,000. A multimeter is a combination of a multi-range DC voltmeter, multi-range AC voltmeter, multi-range ammeter, and multi-range ohmmeter. An unamplified analog multimeter combines a meter movement, range resistors and switches. For an analog meter movement, DC voltage is measured with a series resistor connected between the meter movement and the circuit under test. A set of switches allows greater resistance to be inserted for higher voltage ranges. The product of the basic full-scale deflection current of the movement, and the sum of the series resistance and the movement's own resistance, gives the full-scale voltage of the range. As an example, a meter movement that required 1 mA for full-scale deflection, with an internal resistance of 500 ohms, would, on a 10-volt range of the multimeter, have 9,500 ohms of series resistance. For analog current ranges, low-resistance shunts are connected in parallel with the meter movement to divert most of the current around the coil. Again, for the case of a hypothetical 1 mA, 500 ohm movement on a 1 ampere range, the shunt resistance would be just over 0.5 ohms. Moving coil instruments respond only to the average value of the current through them. To measure alternating current, a rectifier diode is inserted in the circuit so that the average value of current is non-zero. Since the rectified average value and the root mean square value of a waveform need not be the same, simple rectifier-type circuits may only be calibrated for sinusoidal waveforms. Other wave shapes require a different calibration factor to relate RMS and average value. Since practical rectifiers have non-zero voltage drop, accuracy and sensitivity is poor at low values. To measure resistance, a small battery within the instrument passes a current through the device under test and the meter coil. Since the current available depends on the state of charge of the battery, a multimeter usually has an adjustment for the ohms scale to zero it. In the usual circuit found in analog multimeters, the meter deflection is inversely proportional to the resistance. So full scale is 0 ohms, and high resistance corresponds to smaller deflections. The ohm scale is compressed, so resolution is better at lower resistance values. Amplified instruments simplify the design of the series and shunt resistor networks. The internal resistance of the coil is decoupled from the selection of the series and shunt range resistors. The series network becomes a voltage divider. Where AC measurements are required, the rectifier can be placed after the amplifier stage, improving precision at low range. Digital instruments, which necessarily incorporate amplifiers, use the same principles as analog instruments for range resistors. For resistance measurements, usually a small constant current is passed through the device under test and the digital multimeter reads the resultant voltage drop. This eliminates the scale compression found in analog meters, but requires a source of significant current. An auto-ranging digital multimeter can automatically adjust the scaling network so that the measurement uses the full precision of the A/D converter. In all types of multimeters, The quality of the switching elements is critical to stable and accurate measurements. Stability of the resistors is a limiting factor in the long-term accuracy and precision of the instrument.